So let's actually get specific with some of these reactions. All the reactions we're going to do are the nucleophilic acyl substitutions. So every reaction is going to be substituting our X group of whatever we're looking at for a different X group. Now let's list out our derivatives in order of reactivity, and I'm going to put them in anti-clockwise. So we'll start with the acid chloride, most reactive, then we'll go to the acid anhydride, then the acid itself, then the ester, and then the amide. Now, in a very rough sense, you can make any single one of these from another one as long as that other one from which you're making it is more reactive. In other words, it's very hard to turn an amide into any of these other ones. It's very easy to turn acid chlorides into any one of these things. Okay, now I'm going to generally be a little selective in the reactions that I discuss here. Okay, so this is not exhaustive, but it certainly, I think, gives you a relatively comprehensive discussion of it. So let's start off with acid chlorides. What can we do with acid chlorides? Well, the answer is anything we want. The first thing I'm going to point out is we're not going to have an arrow from an acid chloride to the acid, because the way you do that is hydrolysis. I've already mentioned that. You don't want to have these in water, because if you have them in water, if you have them even in damp conditions, then you start getting hydrolysis and it produces HCl gas, which is rather nasty, as it goes from the acid chloride down to the acid. So you can hydrolyze acid chlorides to get to acids. I'm not going to mention that further. You can react acid chlorides with ammonia in order to make an amide here. And I should point out that I'm using so-called primary amides here. We'll talk more about amines and amides in the next module. If instead of using NH3, I had an R on this with NH2, then I would have RNH, which is a secondary amide, and so on, and so on, and so on. So I'm going to put other amides here, but right now I'm just concerned with ammonia reacting to make NH2. So I can make amides from my acid chlorides. I can make esters quite happily from my acid chlorides. The Cl is substituted by the alcohol group there, so there's the alcohol group reacting up, and this is a nice reaction with which to make esters. Okay, you take the acid chloride, you just react it up with the alcohol, no heat, no catalyst needed, you end up making the ester quite nicely. Already said that you can make carboxylic acids by just hydrolyzing the acid chloride. You don't want to do that. Okay, so we're not going to worry about making the acid from the acid chloride, but if we take an acid and we react it with an acid chloride, then of course we make the acid anhydride. And this is a nice way to make acid anhydrides. You don't react two acids together, although you could. Much better to simply react an acid chloride with the other acid to make the acid anhydride. Now, acid anhydrides are the second most reactive. That means you have to be very careful not to hydrolyze them to make the acid. So I'm not going to have a line to hydrolyze the acid anhydride to get down to the acid. Just know that it happens. So you have to be very careful not to expose these to water as well. But another good way to make esters is to react the acid anhydride with the alcohol, and you make the ester in this way. Indeed, because acid chlorides are so reactive, a lot of times when you want to make esters or amides, you don't really start necessarily with the acid chloride, you start with the acid anhydride. Okay, so we can make acid anhydrides into amides, we can make them into alcohols. Very hard to make them into acid chlorides. Now we can, continuing on the little cycle here, turn an ester into an amide. We use an ammonia, but it's a very tough reaction. Ester's not overly reactive, certainly not as reactive as the acid anhydride or the acid chloride. So typically I've done this in a little dot, 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 not a reaction that happens too much. So anyway, acid chlorides, you can turn them into any of the four. It's a good reaction, but sometimes a little bit too vigorous. Haven't put in the hydrolysis to acids because that's not a reaction you want to do. It's a reaction you want to avoid. Acid anhydrides, you can turn them readily and nicely into esters. You can turn them into amides. All of these reactions are nucleophilic acyl substitutions. So we talked about the mechanism of that in the previous movie. Esters, you don't really want to do very much in terms of turning them into amides. Now, of course, I've left the poor little acid all by itself down here. We can turn acid chlorides into acids with water. We don't want to. As I said, we want to avoid it. We can turn acid anhydrides into acids with water. We don't want to do that either. We want to avoid the hydrolysis of this. So what can we do with carboxylic acids? Well, probably the most important reactions that I'm going to put on this little scheme are, first of all, we can turn the acids, which we can make readily easily. You think of all the slides of the synthesis of acids. We can actually turn acids into acid chlorides, not with things like HCl, but by using these other chlorinating agents that we saw when we were talking about reactions of alcohols, PCl3 or PCl5 or thionyl chloride here, SOCl2. Any of these reacted up with an acid will produce the acid chloride. So, for example, one of the most common ways to make amides is you make the acid first, because we've got many ways in which we can make acids. You convert the acid to the acid chloride, and then you convert that with ammonia to the amide. We've already seen, of course, another reaction of acids, and that's when you react an acid with an acid chloride to make an acid anhydride. And you can turn acids into esters. But the trouble is, this is a reaction that's a very awkward, nasty reaction. First of all, you react the acid with the alcohol, because that's how you make an ester. You react the acid part with an alcohol. It's how we made it from the acid chloride. It's how we made it from the acid anhydride. So you react an acid with an alcohol. And indeed, that is how most people say an ester is. It's an acid plus an alcohol. But you need an acid catalyst. You need a few drops of sulfuric acid or phosphoric acid, and you have to heat it up. So it's actually a relatively nasty reaction. If you want an ester, much easier to turn the acid into the acid chloride and then react it up with the alcohol. No acid catalyst, no heat, and as we will see in the next movie, no nasty back reaction. So anyway, a scheme that probably in the textbook would be several pages, doesn't really need multiple pages. These are all nucleophilic acyl substitutions. The more reactive the acid group is, in other words, the better the leaving group, and of course chloride is the best leaving group of all of them, the more reactive it is, the easier it is to make the other derivatives. So acid chlorides can be turned into amides, can be turned into esters, can be turned into acid anhydrides. Acid anhydrides, a little bit less reactive, can be turned into amides, can be turned into alcohols. The reaction to turn into amides is with ammonia. The reaction to turn into esters is with alcohols. Acids you can use to make the acid chlorides. You can use acids to make the acid anhydride by reacting it with an acid chloride. And that's about it for the useful reactions of the acids themselves. Esters don't have a lot of good reactions, and amides don't have a lot of good reactions.